time we were together in math, we learned a new concept, perimeter. We learned that perimeter is the distance around a plane figure. One study tip that we talked about last week was that the word rim is in perimeter to remind us of the outside rim of a drinking glass so that we remember that perimeter is the outside edge of a plane figure. Perimeter is measured in units such as feet, inches, or miles. And when finding the perimeter of a regular polygon, we connected the idea that we could use repeated addition to find perimeter. Like in this example, we have an equilateral triangle. Each side measures 2 feet. So to find the perimeter, we could have used this addition sentence, 2 plus 2 plus 2 equals 6. We then connected the idea that this repeated addition sentence can also be represented by a multiplication sentence. Because we have the number 2 3 times in this repeated addition sentence, we learned that the multiplication sentence 2 times 3 equals 6 was another way of finding the perimeter of this equilateral triangle. And that's a little bit of a review of what we did last week, learning about perimeter. And today we are going to take our learning one step farther as we learn about another concept, area. Area is the number of square units needed to cover a figure without overlapping. Square units look like this. And 1 square unit would be 1 single square. We can then use this idea to find the area of a figure. For example, we're looking here at a rectangle on a piece of grid paper. And we are asked to count square units to find area. Well, the way that we would count the square units is we would look at our grid and we would see that this is 1 square unit, this is another square unit, here's a 3rd square unit, and a 4th, and a 5th. Make note that as we are counting square units on this rectangle, that we have found that the length of this rectangle is 5. That's interesting. We're going to take that little tidbit and use it to apply some further learning in some other examples. So far I've counted 1, 2, 3, 4, 5 square units, 6, 7, 8, 9, 10 square units, 11, 12, 13, 14, 15 square units, 16, 17, 18, 19, and 20 square units. So we would say that the area of this rectangle is 20 square units. Let's see if we can find the area of another shape. Here we have our reminder that area is the number of square units needed to cover a figure without overlapping. So let's see if we can count square units to find the area of this rectangle. This rectangle is a different size than our first example. This rectangle I see is 1, 2, 3, 4 units in length and 1, 2, 3 units in width. Let's see if we can count squares. Here's 1, 2, 3, 4 square units, 5, 6, 7, 8 square units, 9, 10, 11, 12. We would answer this by saying the area equals 12 square units. Let's do another example together. This one takes our understanding one more leap ahead because we know that area is the number of square units needed to cover a figure without overlapping. We've done a couple examples where we counted square units that looked like this, but for this example, we are asked to think about counting squares when perhaps we have to deal with half a square unit. A half a square unit could look like this. A half a square unit could also look like this. Let's see if we can find the area of this right triangle by counting squares. When I look at this triangle, I see that this is one whole square unit. Here's a second full square unit. We have a third full square unit here. We have a fourth square unit, a fifth square unit, sixth full square unit, a seventh square unit, an eighth square unit, a ninth square unit, and here's a 10th square unit. Notice that my full square units do not completely cover this right triangle. We now need to use our mathematical thinking to consider the parts of this triangle that are represented by half a square unit. I see one half square unit here and another half square unit here. When we combine two halves, we get a whole. So this half a unit and this half a unit combine together to make one square unit. And remember that this is because half plus half equals one whole square unit. We again see that there's a half a square unit here and a half square unit here. These can combine to make another square unit. And then I'm left with one half square unit all by itself with nothing to combine with. So all in all, we counted 10 full square units. We have another square unit, an 11th square unit by combining these, a 12th square unit by combining these half square units. So when we combine these all together, the 10 full square units plus one square unit here plus one square unit here, we have 12 full square units plus one half a square unit left over. So we would say that the area of this figure, I'm going to switch colors just so that we can keep it separate. The area in this example equals 12 and a half square units. Let's try another example. Here's an example of a rectangle, and we are asked to find the area. Over here, we can count square units because we're given a grid to find the area of this rectangle. So count with me. I see that I have 1 square unit, 2 square units, 3 square units, 4 square units, 5 square units, and 6 square units. So we know that the area of this rectangle is 6 square units. But I want to open your eyes to this idea. When we see that the length of this rectangle is 1, 2, 3 units long, and 1, 2 units wide, we can find the area by thinking about multiplication. In order to find the area of this rectangle, we can think of this special number sentence, area equals length times width. Since we counted that the length is 3 units and the width is 2 units, I can now use it to make a number sentence. If my length is 3 and my length is 2, I can use this special number sentence, that area equals length times width, to show the multiplication sentence 3 times 2. Now, Mrs. Taglia remembers from last week that multiplication is like skip counting. So if I felt comfortable skip counting in my mind, I might say 3 times 2. Okay, I'm going to skip count by 3's 2 times. 3, 6. So I know that 3 times 2 is 6 square units. But if I wasn't sure how to skip count 3 times 2, I remember that I can also represent this by a repeated addition sentence. 3 times 2 can be represented by the addition sentence 3 plus 3, because I have the number 3 2 times, which also equals 6 square units. So just like last week when we were learning about perimeter, we can find area using multiplication, and we know that multiplication can also be represented by repeated addition. Let's try another example.